Okay, let's see the first question of homework 4. Show that if big X is larger than 0 and Ex is equal to eta, then the probability of big X larger than or equal to root of eta is less than or equal to root of eta. And there's a clue that understand the proof of Chebyshev inequality. So we can first see the proof of Chebyshev inequality. Let's say that the theorem that for any the Chebyshev inequality tells that for any sigma bigger than 0, the probability of big X of this probability of this is less than or equal to the theta square in sigma square. We can see how does it prove. First, it gives us the expression of theta square is equal to e x minus eta square, and is equal to the derived integral of the x minus eta square small fx dx. So we can see that this is from infinity minus infinity to infinity. So we can say that it should larger than or equal to the integral from the area x minus eta bigger than or equal to theta is equal to epsilon, because this area is smaller than the whole area, so this will be larger than this, and this will be larger than this because we can say x minus eta square x minus r is larger than or equal to epsilon, so this part is larger than this part, so we can say this also larger or equal to than this, and this part is equal to, we can take the epsilon square out of the integral, and we can get this, so this part will be equal to the probability of x minus eta and will bigger than or equal to epsilon, so it was proved. And now let's see this question. If x is larger than 0 and ex is equal to eta, then the probability of this is less than or equal to this. So similarly to the proof of Chebyshev inequality, we can write down the expression of ex is equal to the integral of x small fx dx is equal to eta. And similarly, we can say that because this is from minus infinity to infinity, so it will be larger than the integral of the area x bigger than or equal to root of eta. And then we can say this should this x, because x is bigger than root of eta, so this part is also larger than or equal to this part. So from this we can get the eta is larger than or equal to the integral from in the area of x of this area and root
root of eta small fx dx. So we can get this part, and this is equal to the probability of x bigger than or equal to root of eta. So it was proved.